degrees. Now we're aiming for like 5 degrees rise. So if our normal temperature is like 36.5, it goes up to 42.5 degrees, but it's only done in one local area. So in order to produce that sort of temperature, then there is cool pads there's a probe above and below in a bed. So the patient lies in a bed. There's a probe above and below, and there's cooling pads where cold water is running through underneath the probe to keep the probes comfortable along the skin. So on the skin it's comfortable, but between those two probes it's reaching temperatures as high as 42.5 degrees. When we get to those sort of temperatures, the cancer cells really don't like the heat. We have to remember that cancer cells, as they're growing in the body, there's a stage where they grow new blood vessels, normally around 1 or 2 millimeters in size. Then they have to try and grow blood vessels to get more nutrients to help them grow. But these new blood vessels, what we call angiogenesis, are never as good as our own natural blood vessels that we were born with. So what happens is when we apply heat to that local area where the tumor is, that the normal cells can very effectively dissipate the heat, but the cancer cells cannot. And they get hotter and hotter, and when they do, the protein that protects it begins to break down. Not only that, but they will release what are known as heat shock proteins to try to repair themselves. And as soon as they do that, the immune system can see it and attack it. So it also has an effect in unmasking and revealing the hidden tumor cells.